All right, geometry, we are on lesson 3. We've got perpendicular bisector, angle bisector, altitude, and median. Some of this we've heard before. Some of it will be new material. We're going to do a lot of pause and stop so I can try to keep this video as short as possible. I've written down the definitions, so when we get to one, you can pause it, write the definition down, and then continue on. We're going to identify our perpendicular and angle bisectors, the median of a triangle, which is a new statement, the altitude of a triangle, which is new, and then we'll apply everything that we learned into solving a triangle. So the first thing I want you to do is write down the definition of perpendicular bisector. Take a minute, pause the video here, and write down what I have written. All right, so we're back. You have that all written down. A perpendicular bisector is a line that intersects a line segment. So here's our line segment, and our perpendicular bisector bisects that line segment at a perpendicular angle, at a right angle, and it is the midpoint of the line segment that it intersected. Notice these are two congruent sides. So if I said this was 5 inches, you would be able to say this was 5 inches. If this was x plus 5, and this side was 12x plus 45, all we would want to do is set those two guys equal to each other and solve for that. So it's a matter of where do we put that equal sign. Let's make that in our notes. Where does our equal sign go? Once we know that, we can solve anything. Angle bisector. Take another minute, pause, and write down these definitions. Angle bisector, median, and altitude. All right, so we took our minute. You're back. You've got these all written down. So an angle bisector, we already know, is a ray that divides an angle into two congruent angles. That one is information that we knew already, but we're going to use that to apply it to new triangles. So what do we know about our angle bisector here? We know that BD, ray BD, bisects angle ABC. So we know that that created two congruent angles. What is a median? That is a new vocab word for us. A median is a segment that connects the vertex, I forgot the E there, that connects the vertex of a triangle to the midpoint of the opposite side. So in this one, B would be our vertex angle, and we're going to the midpoint of the opposite side, noticing that it splits this line segment into two congruent parts. So AD is congruent to DC. We can do that from any of our vertexes. If I wanted to go to the midpoint of this line, creating two congruent segments, that would be the median of that. Erase that guy. And what is the altitude? Our last new vocab term. Altitude. What do we think of when we think of altitude? I think of planes flying in the air. We reach the altitude of 30,000 feet. So I like to say, how high? How high is it? So we can find out how tall our triangle is given any vertex that we choose. So it's a segment that connects the vertex to the opposite side at a right triangle. And that'll give you how high the triangle is. Notice there's no congruent parts in this. We just go from how high the triangle is. So let's say we had a triangle like this, and we wanted to find out how high that guy was. Well, if we connected a vertex to form a right angle, we wouldn't be able to do that. We connected that, that doesn't form a right angle, that doesn't form a right angle. We could find out what that right angle is, but say we wanted to form it the way that our triangle is just set up, we could draw an altitude from the vertex on the outside of the triangle forming a right angle, and that would tell us based on that vertex how high that triangle is facing that direction on that vertex. It should be note 2. We've got a note on here. Line segment BD is an altitude. Tells us how high that triangle is. Some examples, it says identify BD as a perpendicular bisector, angle bisector, altitude, and or median. These can be more than one answer. I know that the answers are already given to us, but let's just check out what we got going on here. So we're going from a vertex of one angle to the midpoint of the opposite side. I know it is a midpoint because it breaks it into two congruent pieces. So on this one, we have a median. So we're going to have to memorize these terms. The median goes from a vertex to the midpoint of a line segment. So that one would be median. If we want to intersect a line segment at a right angle at its midpoint, we're going to find the midpoint of the side, which would be here. Noticing it breaks it into two congruent segments, and then we're going to go straight up to form a 90-degree angle. So that one is a perpendicular bisector. It didn't go from a vertex, but it did break our line segment into two congruent pieces. For the next one, if we go straight down from a vertex to form a 90-degree angle, that is an altitude. And the last one, we went from the vertex to form two congruent angles. Notice there's no congruent sides in this, but we do have two congruent angles. So that one is an angle bisector. Some theorems and converses. Again, pause this to write the definition down, and then we will talk about what the definition means. All right, so you're back. Perpendicular bisector theorem. If a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of a segment. So even going back up to our original, if we were to connect these 2 points, they would be equidistant away from our perpendicular bisector. So I know that those would have to be congruent. That is going to be what the perpendicular bisector theorem states. If it is equidistant from the endpoints of the segment, then it is the perpendicular bisector theorem. So I know AC is congruent to BC. If CP is a perpendicular bisector, which we've got that 90-degree angle. It already tells us in our diagram that we've got two congruent segments, so we know that that's true. So based on this next drawing, what can we conclude based on the theorem that we just talked about? We know from Unit 2, if one right triangle is formed, we have 4 right triangles, right? So this must also be a perpendicular bisector. So if WX I'm sorry, let me go back. If, yeah, no, I was right. If, let me extend this. Since TV is congruent, they're both 25 degrees. I know it's small, I apologize for that, but they're both equal to 25, so we know they're congruent. So if TV is congruent to ZY, ZV, then we know that WV is a perpendicular bisector, and we would be able to solve that triangle algebraically if we were given some x's and y's. The converse, remember, we're just switching our p's and our q's. So if a point is equidistant from the endpoints of a segment, then it is on the perpendicular bisector. Press pause, write these next two down, and then we will talk about them. So if a point is equidistant from the endpoints of the segment, then it is on the perpendicular bisector of the segment. Notice I've got a right angle here, and I've got two congruent, so I know that that is a perpendicular bisector. Since these two lines are congruent, we can apply the perpendicular bisector theorem, or the converse of the perpendicular bisector theorem, excuse me. So if AD is congruent to BD, which we know they've told us that in the diagram, then D is also, if we were to extend this line, D is on the perpendicular bisector of AB. We would be able to extend that line down again, knowing that that is a perpendicular bisector, and we would be able to solve that triangle. Angle bisector theorem, if we have that written down, hopefully we do. If a point is on the angle bisector, then it is equidistant from two sides of the angle. So what can we conclude from this? If D is on the angle bisector of angle BAC, point D is on my angle bisector, because these two are congruent, right? Then I know that DB must be congruent to DC. Let me write that down. This must be congruent to this. So if D is on the angle bisector, of angle ABC, then DB must be congruent to DC. Sorry, this got a little squished. So if D is on the bisector of the angle, D is on the bisector here, and I'm connecting these two pieces together, I know that those two segments have to be congruent. Now I have my equation and I can set that up. The converse, we're just going to flip that around, pause it quick if you haven't written this one down yet. And if you're back, it is a point that is equidistant from the two sides of the angles. Then the point is on the angle bisector. So if I'm given that BD is congruent to CD, then I know that point D is on the angle bisector. So what can we write down? If DB is congruent to DC, then D is on the angle bisector of angle ABC. So we just went backwards. We said if D is on the bisector, then those two pieces must be congruent, and our converse, if those pieces are congruent, then D is on the angle bisector. So I know that was a lot of information squished together. We're going to do a couple practice problems together. If you have any questions, let me know. So we're going to find the value of x. Let's see what we're dealing with here first. We've got two congruent pieces, and we have a right angle. So we know that this is a perpendicular bisector. If this is a perpendicular bisector that breaks this into two congruent pieces, I know that this side has to equal this side. So we know that we can set our equation up as 7x plus 24 is equal to 13x minus 48. Finish that, solve it for the value of x, and then submit your notes when you're completely done. Angle bisector, they're telling us that XZ is congruent to YZ. So we know Z is on the angle bisector of angle angle XWY. We know that Z is on the angle bisector, therefore XZ must be congruent to YZ, which we already know because they told us that. So since it's on the angle bisector, I know that these two angles are congruent because it bisected those angles into two congruent pieces. So based on our diagram here, since these are congruent and Z is on the bisector, I can set my equation up to look like 8x minus 32 equals 3x plus 3. Sorry, I know that was a lot of information. Hopefully that made sense. If it didn't, reach out to me. Let me know if you have any questions at all. We're talking about basically solving equations given the perpendicular bisector theorem and the angle bisector theorem, which is information that should be semi-familiar to us. It's just a matter, again, of how do we set up an equation given the info we know. Okay, let me know if you have any